When using conductors connected in parallel, each conductor must have an ampacity not less than the ampacity of the circuit. This means each individual conductor in the parallel configuration must be capable of handling the full current load of the circuit. Conductors used in parallel must adhere to specific requirements. Firstly, conductors must be of the same type. Secondly, conductors must be of the same size. Thirdly, conductors must have the same insulation. Fourthly, conductors must be connected in the same phase. The ampacity of each conductor must be at least equal to the ampacity of the overcurrent protective device protecting the circuit. The purpose of using parallel conductors is to increase the current carrying capacity of a circuit. Instead of using a single large conductor, multiple smaller conductors are run in parallel to achieve the desired ampacity. The ampacity of a parallel circuit is equal to the sum of the ampacities of the individual conductors. For example, consider two 500 kc multi-HHN copper conductors connected in parallel. Each 500 kc multi-HHN copper conductor has a certain ampacity rating. When connected in parallel, their combined ampacity is additive. In this example, the two 500 kc multi-HHN copper conductors connected in parallel have a combined ampacity of 1000 amps. This is the same ampacity as a single 1000 kc multi-HHN copper conductor. There are several benefits to using parallel conductors. Firstly, increased current carrying capacity is achieved. Secondly, low voltage drop occurs. Thirdly, improved heat dissipation is obtained. Fourthly, it provides flexibility in design. By using multiple smaller conductors, the overall current carrying capacity of the circuit is increased, allowing it to handle larger loads. When current flows through a conductor, there is a voltage drop due to the conductor's resistance. By using parallel conductors, the overall resistance of the circuit is reduced, resulting in a lower voltage drop. This is particularly important in long circuits where voltage drop can be a significant issue. Parallel conductors provide a larger surface area for heat dissipation compared to a single large conductor. This helps to keep the conductors cooler and reduces the risk of overheating. Parallel conductors offer greater flexibility in design. They can be routed through tight spaces and around obstacles more easily than a single large conductor. Consider National Electrical Code Section 310.15b. This section covers conductors connected in parallel. It specifies that where conductors are connected in parallel, each conductor must have an ampacity not less than the ampacity of the circuit. Understanding these requirements and benefits is crucial for designing safe and efficient electrical systems.